Change in sediment influx into the GBR due to anthropogenic change has been documented using trace element to calcium ratios in the Burdekin by Lewis et al. And McCulloch et al. Recent studies by Bartley et al. In the Burdekin and Ollie et al. In the Normanby catchment have shown that fine sediments, 4 to 16 micrometers, originate from subsurface erosion, such as stream banks and gullies. Of those sediments, around 80 to 90% are stored along the end of system zone, such as in estuaries and deltas pictured here. Large rain events, wave, wind, and tide interactions can resuspend the finer sediments, which form plumes that can travel far offshore, such as this one. Using sediment source tracing, erosion mapping, and catchment modelling, Wilkinson et al. Identified gully erosion as contributing 40% of all fine sediment to the GBR. Haitley highlights early attempts to model the GBR particle transport applied data from the Burdekin River to all Queensland catchments. This tended to overestimate sediment loads, particularly in the northern GBR catchments. Kroon et al. Cites factors that dictate sediment delivery to the GBR, such as yearly rainfall amounts, intensity, vegetation, topography, land use, and soil types may actually vary from one catchment to the next. The Paddock to Reef Monitoring Program, launched in 2009, uses a combination of monitoring and modelling to assess water quality runoff into the GBR. The wet tropics is approximately 5% of the total GBR catchment area and consists of the Daintree, Mossman, Barron, Mulgrave Russell, Johnston, Tully, Murray and Herbert catchments. Wet tropics modelling approach. A range of models are integrated into the e-water source catchments framework. Modelling found that TSS in the wet tropics were from hill slopes predominantly, followed by stream banks with minor contribution from gullies. Only 3% of total suspended solids are lost due to deposition, with 97% of TSS being exported to endless stream systems where freshwater streams or rivers join estuaries or the sea. The largest contributor of TSS load was from the Herbert Basin, which delivered 38% of the wet tropics load. Grazing areas were typically the major source of this, and Silber noted that ground cover is a key driver of sediment loss, and on average, the drier parts of the Herbert Basin is drier than other parts of the wet tropics. Improvements that can be made. Most model loads were lower than the estimates from measured data. This is most likely due to the under-prediction of hydrology. Gully density mapping is largely based on the coarse mapping, and opportunities exist to improve this layer. Deposition of fine sediment and particulate nutrients is modelled on floodplains and in storages, and no attempt to include in-stream deposition or reentrainment of fine particles has been undertaken.